Page 24, example 10. Okay, so we have 2 pages left. Both of them, they are motion questions. Before we start doing that, let's just think about like the formulas might involve in the motion questions. We have 2 things, basically it's very important. One is called average velocity. And then we have average speed. Well, those 2 is very important. So average velocity is x2 minus x1 over time 2 minus time 1. So it's the change in displacement minus the divide the change in time. So for example, at time 1, I'm at 1, positive 1. And at time 5, I'm time t equals to 1. I'm at a position of 1. And when t equals to 6, my x2 at that time equals to, say, 11. So my average velocity will be 11 minus 1. That's 10 on top, and then divide by 6 minus 1. So divide by 5. So which is 2. Okay, it's 10 divided by 5, which is 2. That's my average velocity. So the average velocity is move 2 units to the right every second. Okay, move 2 units to the right every second. That's average velocity. So average speed is the total distance covered by time 2 and time 1 to time 2, and then we divide by the difference between the time. So in 1 second to 5 seconds, I have traveled like anyway, like this way, keep moving. I traveled in total 100 meters. Then it's 100 divided by 4 seconds. It's 25 meters per second. So it's the total distance covered between time 1 and time 2. So that's average speed. And the next really important thing is VT graph. Okay, so for VT graph, you can find all of this in the previous booklet. Okay, don't really need to copy that. So for VT graph, we have signed area equals to displacement. Because for displacement, we take the sign into consideration. But for total area, we got distance. Okay, for total area, we got distance. So in between 2 time, in between time equals to something, time equals to something. In between that, if we talk about the signed area, that will be the displacement. If we find the total distance, that will be the distance. The total area is the distance. So if I want to find signed area, I can just do integration between time 1 to time 2. That will just give me the signed area. But for total area, I need to see the graph and then see where's the x-intercept and then integral from different side. Okay, let's have a look at this example. The position of a particle x meters from the point O at time t seconds is given by xt equals to 2t squared minus 7t minus 15, which t greater than 0. Find the initial position of the particle. Okay, initial position which is t equals to 0. So we have minus 15. So it's on the negative direction of the origin of 15 units. Okay, so 15 meters. The position of the particle after 6 seconds. So we find x6. So 2 times 36 minus 42 minus 15. That is 72 minus 57. And that equals to 15. Okay, now it's positive 15 units. And that's positive 15 units. So the distance traveled. Okay, let's move C and D after E. Okay, let's move the direction. So we do E first. Ask the average velocity over the first 6 seconds. Okay, ask for velocity. So if it's velocity, that will be the final. Okay, so 0 seconds to 6 seconds. So I want the position at time 6, so which is 15, minus the the position at time 0, so that's minus 15. We subtract them. So final position minus the initial position over 6 minus 0. So that gives you 30 over 6, and that's 5 meters per second. Okay, let's do the next one first. F, the particle's initial velocity. So this is xt. So if I want to find vt, I need to differentiate. Okay, so when we differentiate 14 minus 7, okay, it's a linear. The good thing is a linear. And the initial velocity will be v0. That's minus 7 meters per second. So it's moving to the left for 7 meters per second. Yeah, let's move C and D in the end. So next is when and where the particle is instantaneously at rest. Okay, so for that second is rest. So we want Vt equals to 0. So we want 14 minus 7 equals to 0. Make your velocity equals to 0. So T is 7 over 4. So when, like at 7 over 4 seconds, is instantaneously at rest. And where, okay, don't forget the where. Where is talking about this placement. So it's x. Okay, it's x. So x 7 over 4. That gives you 2 times 7 over 4 squared minus 7 times 7 over 4 and minus 15. That's 49 over 8 minus 49 over 4 minus 15. So that's minus 49 over 8 for the first two and minus 8 over that. And this gives me negative 169 over 8 meters. Forty-nine, 16 times 2 is 8, and then minus that. Okay, half of that, so minus 49 over 8, and then minus 15 is 120 over 8. That's correct. So that's the position when it's instantaneously at rest. And H says the velocity of the particle as it passed through the origin. Okay, pass through the origin is I want my displacement to be 0. So needs to be at the position. So x needs to be 0. X equals to 0 means I'm at the position origin. So I have 1, 2, 15. Okay, it's 3 and 5. So 5 and 3. I need minus 7. So minus 10 plus 3, that gives you minus 7. So what I have is t minus 5 and 2t plus 3. Well, 2t plus 3 doesn't work. So t equals to 5 only. Okay, t equals to 5 only. And then velocity v5 give you 20 minus 7, and that's 13 meters per second. So when it passes through the origin is 13 meters per second. Okay, pass through origin. means x equals to 0. There's no displacement. Factorize, solve equals to 0. I have time equal, well, positive time only. So t equals to 5 only. Any, haven't finished. We have 2 more. Why I talk about E and first before we do C and D? Because if I want to find distance, I must use VT graph. Okay, if I want to know distance, I must use VT graph because it's the total area. It can't be easily done like displacement directly sub. I can have the displacement. So, well, this VT graph is an easy one because it's just a linear. So it's 14 minus 7. So we want VT graph. That's 6. For the first 6 seconds, that's 6. And I have minus 7. And y sub 6. Well, I'm not really draw it to scale, like because it's very hard to draw it to scale. So it will be an increasing function that with 14 minus 7. With 14 minus 7, v equals to 14 minus 7. And I can find this point is 7 over 4. It's 7 over 4. And this point is minus 7. This point is minus 7. Okay, so for the first 6 seconds, okay, for the first 6 seconds is the area here and the area here. Okay, it's those two areas. So if I add those two areas, that will give me the distance. Okay, it will give me the distance. So if I say this is A1, this is A2. Well, I don't really need to use integral. I can just directly use triangles to find that. Okay, so for the A1 equals to a half times 7 times 7 over 4. That's 49 on 8. Six minus 7 over 4 equals to 24 over 4 minus 7 over 4. And it's 17 over 4. Okay, so this part is 17 over 4. And here is V6. V6 equals to 24 minus 7. That equals to 17. So A2 equals to a half times 17 over 4 times 17. That equals to 289 over 8. Okay, so we find the two areas. One area is 49 over 8 and the other area is 289 over 8. Okay, we can check whether we get the correct thing or not. You know, for the first 6 seconds, I work out that my displacement should be a 30. Okay, my displacement should be a 30. We use x2 minus x1. Now we can use a2 minus a1 to check if we have the correct thing. So if I use a2 minus a1, that's 289 over 8 minus 49 over 8. And that's 240 over 8, and we got 30. So it is the correct area we find because we subtract them. That should give me the displacement, which is the same as the other way we do it, x2 minus x1. So then if we want distance, I need to use a1 plus a2 to work out that. So that's 49 plus 289 over 8. So that's 338 over 8. So divide that by 2. Divide that by 2, we have 4. Divide that by 2 is 168. 9. 169 over 4. So that's the distance. Okay, we're adding a1 and a2. That should give me the distance. If we subtract that, that should give me displacement. Okay, this one is displacement. So now find the average speed between this first 6 seconds. That's the total distance covered divided by the time. Okay, divide by the time. And that's 169 over 24 meters per second. That's the average speed. Okay, so average distance divided by the time give me the average speed. Questions? This is a revision. Okay, this question is a revision. We do exactly the same things before in the previous notes, because I want you to think about the next question. I want you to think about the next question. That's really important. The velocity of an object vt is given by 3 pi cosine pi t over 4. Okay. Can you draw the first 20, you can draw 16, like just give me something, it's not really a period, draw from t equals to 0 to t equals to 16 or 18 or 20, like close to that area. So about 20 will be a good one because ask me 15 seconds, 15 seconds and 20 seconds. So 20 seconds is where I need, I think. Or you can just draw until 15. Okay, or any point close to that point. So just draw this graph for me first. Okay, what's 3 pi cosine pi t over 4 looks like? Okay, we just quickly do that. Should have some graph looks like this. Well, I draw up to 20. You can draw up to 16 because period is 8, so you can draw 2 periods. So this is the most original shape for cosine. There's no reflection, nothing happened. It's the easiest one to sketch. Start from the top and follow the pattern. All you need to find is the period, and period divided by 4 each step. You will take in horizontal, which each step takes 2. So the maximum point start at 0, so 0, 3 pi, and then to 0, 4, negative 3 pi, and then keep going. Okay, if you haven't finished that, it's alright. I just don't have much time left. I want to finish this up. You can have a look at this shape. You should have something similar to that. But what I also talk about is circular functions, they are all symmetrical. Okay, they are all symmetrical. So the area I shade now using different colors, they are all the same area, same size of the area. Well, you should be able to see it. It's all symmetrical. So they are all same. So that area, that, the small pieces, they're all the same. Okay, I cut in half, I cut like one parabola shape into half, and then they should have the same area for each side. Okay, so the question asked me, the first is the displacement, and the second is asked me the distance. And third one asked me when it will be stationary for the first 20 seconds. Well, the last one is easy to answer after I draw the graph. That's t equals to 2, to 6, to 10, to 14, and to 18 seconds. That will be stationary. Okay, you can see from your graph 2, 6, 8, 14, and 18. Okay, this is the t-axis, this is the v-axis, this is the vt graph. So on the x-intercept shows you v equals to 0. Okay, now for A, if you talk about the integral, okay, okay, this should be the integral, okay, first 15 seconds is the integral 0 to 15 of 3 pi cosine pi t pi over 4t dt. Okay, so what I will have is three pi times 4 over pi, cosine become positive sine, pi over 4t. And from 0 to 15. And that is 12 sine 15 pi over 4 minus sine 0. Okay, sine 0 just 0. Okay, we don't need sine 0. Sine 0 is 0. And 15 pi over 4. That gives you sine minus pi over 4. Because I minus 4 pi for that. 4 pi is 16 pi over 4. So minus 4 pi. And you know minus pi over 4 is here. Is in the cosine quadrant. That's a minus 12 sine of pi over 4. That's 12 times root 2 over 2. That's minus 6 root 2. Because to talk about the sine area, you just do the integral. But let's have a look. Well, I know you can do the calculation, but let's have a look. What is the important thing? We want to find the integral between 0 to 15. Can you see, actually we talk about sine area. This one and this one were cancelled. This one and this one cancelled. This one and this one cancelled. What has been left is the pink area minus the white area. That's all we need, right? Like, when we integrate from 0 to 15 is exactly the same as the pink area minus the white area. That's the area giving you like the sine area. Because they all get cancelled, become 0, 0, 0. So the only thing left is there. So the pink area, let's say we say this is A1 and this is A2. Okay, A2 will be the same area as all of this. Okay, A2 is all the same area as all the things above. Let's calculate what is A2. Okay, A2 will equals to what? A2 can be 0 to 2 of 3 pi cosine pi on 4t dt. Because I said this empty area, it will be the same as all this area here. So I can use any interval to calculate the area. So I just choose two easy numbers to calculate. 0 to 2 is a good number to do the calculation. So A2 will equals to what? Equals to 12 sine pi over 4t. And I sub 0 to 2. So what I will have here is sub 2 in, that's 12 sine pi over 2 minus 12 sine 0, and that's just a 12 because sine pi on 2 is 1. Okay, 0, 1, sine pi on 2 is a 1. So A1 equals to what? A1 equals to 14 to 15. Of this. Okay, 14 to 15. The pink is the 14 to 15 of this. So A1 equals to 12 sine pi 4t, 14 and 15. That's 12 sine 15 pi over 4 minus sine 7 pi over 2. Okay, 14 over 4 is 7 over 2. Okay, 14 over 4 is 7 over 2. So A1 equals to, okay, what we have here is, this is 14 to 15. Okay, what's this? Sine 7 pi over 2. Okay, is at this place. Okay, 7 pi over 2 is at this place. So it's a 12 bracket. Remember we evaluate this. Evaluate here. That give you negative root 2 over 2. It's a negative sine pi on 4. and then we minus of a -1. Okay, sine 7 pi on 2 is a -1. So my A1 is minus 6 root 2 plus 12. Okay, plus 12. I just write this here. So this area equals to 12 minus 6 root 2. And this area A2 here gives you 12. Okay, you can see, as I said, the sine area is just A1 minus A2 because all of this previous area get cancelled each other. So A1 minus A2 just left with -6 root 2. And it's the same result as we achieved here. Okay, it's -6 root 2. I just show you two different methods what you can do. You can directly integral that, or you can find the two areas separately. But it will be good you find the two areas separately because we can directly use the result in part B. Why? You can count like the total area, right? The total area is 1, 2, 3, 4, 5, 6, 7. 7 lots of A2 plus the A1. Okay, it's 7 lots of A2 plus a little bit there, A1. So it's 7 times 12 plus bracket 12 minus 6 root 2. Okay, 7 lots of A2, the 12, plus the A1, that's the A1. So we add all the area together that give you the distance. So what we have here is, okay, so we have 8 of that. So 8 times 12 minus 6 root 2. And that's 96 minus 6 root 2. So that's the distance. There's a huge difference between the distance and displacement because this particle is moving like this. It's moving like this. And the displacement is only changed a little bit every time. But the distance has covered a long meters. So the distance is 16 minus 6 root 2. Okay. So you think about whether the area get cancelled or is that like we count all of that in. So the 7 of A2 and then plus the A1 is the distance. Okay, that's the end of chapter 11. Yes? Yeah, you can. Like 14 to 15 is the same as 2 to 1, so it gives you the same area. So you can do the same thing.